Ever wondered how stars are born, live, and then die? Let's take a trip across millions of years of star life cycle in just over 60 seconds. All stars begin their life cycle as a little humble cloud of dust and gas. We call that a nebula. Forces of gravity pull together that cloud of dust and gas until we form the next stage, a protostar. As more and more matter is pulled closer and closer together, temperatures and pressures start to increase. Eventually, the star is so hot that the nuclear fusion of hydrogen gas into helium gas can begin. At this point, the star has entered its main sequence. This is a nice, stable phase of a star's life cycle. The outward pressure from that nuclear fusion balances with the gravitational force pulling things in. Our sun right now, it's in its main sequence. In fact, around halfway through its main sequence of 10 billion years, it's about 5 billion years through. Now, matter is not infinite. There's not an infinite supply of that hydrogen fuel for this nuclear fusion of our main sequence star to continue forever. No, eventually it will run out, and what happens next depends on the mass of our star. Stars like our sun and those smaller will eventually expand into a red giant. Eventually, the red giant will shed away its outer layers. That forms a planetary nebula, by the way. And in the end, all that's left is a really hot, really dense core. Named after its glow, it's a white dwarf. Give it many more years and it will eventually cool so much that it loses that glow and becomes a black dwarf. On the other hand, if the star has a mass much greater than our own sun, after its main sequence it expands way more and becomes a red supergiant. It's during this phase that nuclear fusion of heavier and heavier and heavier elements occurs, all the way up to iron. Fun fact here, the massive amounts of energy that are released in a supernova explosion is the only way that heavier elements than iron have been produced. So that includes things like gold, silver, uranium, platinum, anything heavier than iron. All of those things are the products of a massive supernova explosion. They're basically stardust. How cool is that? Following on from that supernova explosion, again, depending on the size of this massive star, that determines what the next bit would be. Slightly smaller ones produce this hot, dense, really fast spinning core called a neutron star. But if it's super massive, you produce this thing called a black hole with gravitational pull so strong even light can't escape. And here's the diagram to summarize. Save this so you can watch it before your exam. I really hope that was helpful, and let me know in the comments, guys, if there's anything else I could make you a quick video for physics paper 2. You're gonna smash it.